All right, I'm back to recording. Okay, so you guys have gotten this sheet out, and we are looking at this document right here that you need. Okay, so everybody should have this document out, and hopefully you are seeing it. Hula Hoopla. Kate, are you seeing this? Imagine's got his hand up. Okay, Imagine, how can I help you?
It's like really, really blurry, like every single word.
Every word is blurry. Is
Everything.
anybody else having that issue? Because that's weird. Not ever had that issue before. Nate,
Yeah,
are you
it's
seeing blurry?
blurry.
It's blurry. Okay.
Not for me, I can see it.
Not sure I understand. It's not blurry. Sometimes it is. It's not for PJ. We can't see the screen. What the heck? I don't know, guys. So Nate, are you seeing the Hula Hoopla lab sheet right now?
I could see it perfectly.
You can see it perfectly. Okay, thank you for that. All right, so if you guys can't see it perfectly, then that's on your end. I'm afraid to say, because it's not blurry here. Okay, so you have, of course, the paper in front of you, so you know what it says. So we're going to look at the background information on hula hooping to give you a little bit of physics behind it, to kind of keep that in mind while we're doing this. So hula hoop spin is a result of centripetal force, which is an inward directed force that results from your body pushing on the hoop. This is also called torque, which is a turning force that keeps an object spinning. Torque, friction, and inertia all play a role in keeping the hoop from falling to the ground. Friction is a force created when objects come into contact with one another. Friction resists motion. When the hips come into contact with the hoop, then that keeps the hoop from falling down, and it allows the hooper to keep on applying torque. So that's how friction is involved. Inertia, which is Newton's first law, is a property of an object that keeps it staying in motion. Mass plays an important part in inertia, as we've been examining lately. Objects with greater mass have more inertia than those with less mass. So once in motion, it will be more likely to stay in motion than the lighter objects, but more force will have to be applied to accelerate it, or get it moving from rest. So the purpose of this lab is to investigate how the mass of a hula hoop affects the speed at which the hula hoop spins. So the first thing that we're going to do is set our hypothesis. So notice in procedure number 1, make a prediction as to the results of this investigation. So we're going to make a prediction right now about the larger the mass of the hoop. Do you think that it's going to move faster or slower if you have a larger mass hoop? And keep in mind Newton's second law. Remember that Newton's second law says more massive objects require more force to make them accelerate. So we know we're going to have to apply more force. In force equals mass times acceleration. That's Newton's second law. So what do you think is going to happen to the speed? Remember, acceleration is the change in speed over time. So do you think a hoop with more mass is going to have go faster, spin faster, or slower? Nate, for some dojo points, what do you think? What's your prediction, Nate?
I think it's going to be pretty slow, but when you add more force with the wrist and like flicking it around, you put more of the acceleration on. Does that make sense?
So then overall, so you said like if you were to use the same amount of force as a light one, like it might move slow, but you're thinking like once it gets going and moving, it'll move faster if you apply more force, or slower? I'm not exactly clear.
Yeah, I'm saying like it'll be slower and you need to put more force into it.
Okay. All right. And oops, you're not Toby, you're Nate. All right. Nate, I just have given you a dojo point. I'll turn my ringer back on so you can hear it. Okay, so Nate thinks it's going to be slower. And anybody else, raise your hand if you think you agree with Nate. You're going to say that it's slower. Raise your hand if that's what you're writing down right now. That the larger mast hoop will be slower spinning. PJ's clapping. Theo's raising his hand. Okay, so Theo thinks it's going to be slower. So then the rest of you think it's going to be faster? The larger mast hoop is going to be faster because you're going to add more force, so it's going to accelerate more. Either way, you want to write that down now. So the larger the mass of the hoop, and you write down either faster or slower, the speed of the hoop, because more massive objects require more force to make them accelerate, according to Newton's second law, force equals mass times acceleration. All right, so now what we're going to be doing is we're going to start to collect our data. So look at the data table here on the second page. You will see that this data is going to be for 3 hula hoops. If you are participating along with us and you're using the bucket and rope, then you guys might say, let's see, this would be the bucket with the most mass. So you'd put like all your objects in that, like 2 different objects in your bucket. Here you'd have just 1 object in your bucket, and for your hula 3, which would be your smallest mass bucket, that'd be your empty bucket. And if you were doing the pencil and the rubber bands, then you would have your biggest rubber band, medium-sized rubber band, and smallest rubber band here. All right, and then what we're gonna do is we're going to make our hoops or buckets or rubber bands spin for 30 seconds. And we're going to do this 3 times. And we're going to count how many rotations happen in those 30 seconds. And then we're going to multiply by 2 to get how many rotations in 1 minute. Instead of doing it for 1 minute and taking longer. Okay, so we are about ready to start. So this is where we're going to record our information. You want to have a timer ready and a calculator. Okay, so, all right, you should be back on me now. Okay, so here we go. And if you raised your hand to vote on your hypothesis there, you can put your hands down now. So I don't think you want to ask a question. And if you do have a question or you want to supply some information, please do so. I've got my phone handy for Dojo and for a timer. Okay, so, all right, let me show you guys. The mass, we're investigating how mass affects the hoop, the speed of the spin of a hoop. So the different massed hoops are here. Okay, so we have our 3 hoops. And just to show you that they have different masses, I am going to introduce to you a tool you've probably never seen before, and it's called the spring scale. And the spring scale looks like this. And what this measures is gravity, really. I'm sorry. It measures not gravity, but weight. And remember, weight is the measure of how much gravity is pulling down on an object. So we can hang our object here, and then it'll pull the spring down inside. And if you look closely, there are numbers here. And there's a big N, stands for Newton. And Newton is the unit we measure force in, which we learned about in our notes. And so on the other side, actually, it does have grams, so you can measure mass this way too. So our largest hoop has a weight of, sorry, the hoop's a little wide, but I can make it work, because I did it before. Oh, of course. Now it doesn't. Sorry, guys. Just wanted to show you. All right. So, well, it was on there for a minute. And it had I measured it yesterday. It had a force of 4 newtons. So its weight was 4 newtons. And you might see that it's down there at 4. And just to save us a little bit of time on this, because I see our time is going away, the middle one has a weight of about 3 3/4 newtons, so it's a little less. And the smallest one has the smallest mass. And maybe I can do this one real quick, show you. It's a little bit easier. And this one has a weight of 3 newtons. And maybe you can see that. All right, so remember, if you are using your bucket, we're going to start off with the heaviest. So you'll have your objects in your bucket to give it some mass. You've got your string or your rope. And you will swing like this. And you will count how many times the bucket maybe goes at the top of your circle. And you're going to have a timer set for 30 seconds. All right. The other option was the rubber band on the pencil. And I'm going to do the hula hoop. All right, let's get started. So you got your timer set for 30 seconds. And I am going to start with the biggest hoop. I call this hoop Batman. If you look closely, it's got Batman signals on it, or symbols on it. And these hula hoops, I've been using them in the classroom for a couple years. They are a little bit beat up. So anyway, a nice smooth hoop would be better. Oh my gosh, it just broke. Isn't that nice? That's never happened before. Okay, so then let me put this back together. Oh, what a day. Okay, so we are going to start again. All right, timer is ready for 30 seconds. I'm ready to start hooping for you. Okay, and here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, and whew, I think that was 36. All right. It's a pretty good workout. All right, cancel. It is one of those days, I'll tell you what. Okay, so let's write that down as 36 for the big hoop. And we're gonna double that. So that would be what, 72, wouldn't it be? 35 and 35 is 70, yeah. So 72 rotations a minute for the big hoop. All right, now we got purple lightning. This is my medium-sized hoop. Yes, you can use the restroom. Whoever is asking me that, that's funny. Yes, Bryson, go ahead. Go use the restroom. Derek doesn't have a big hoop. PJ's thinking it's going to be slower. Okay, thanks for the chats, guys. I didn't see those earlier. Okay, so here we go with the medium-sized hoop. And again, you might be using the hoop instead of on your waist. Maybe you're using it on your arms, right? Or maybe you're using it on your neck. Oops. But whatever you are doing, make sure you keep it consistent. So don't do one hoop on your waist and one hoop on your arm. we need to keep it consistent because remember, in an experiment, the only thing that we want to change is the independent or manipulated variable. And in this case, who can tell me what would the manipulated variable be? Anybody? Yes, John.
Wouldn't it be the hula hoop?
What about the hula hoop?
The mass.
Yeah, right on. Good job. You get dojo for that. Okay, so let's now do the medium hoop. And some of you predicted that this was going to be a little bit slower. Some of you might have predicted it was going to be faster. So let's find out. All right. Back to my timer. Okay. It's kind of hard. So if you were doing this in class, you'd be doing this with the partner and somebody else would be timing it and counting. So it's kind of hard to do by yourself. Hope you guys are doing all right out there. All right, here we go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, and it's raining. All right, 40. So 40 times 2, because it was 40 and 30 seconds, we're going to do it every for 1 minute. So if we double that, it would be 80 rotations in 1 minute. So that's bigger. See Yogi back there. So that's faster. All right, now we're going to do the third smallest hoop. And this one, this hoop, it's my arch nemesis. This one right here, I call the Blue Devil. I really have a hard time with it. I almost did not choose to do this around my waist because I'm not positive I can do this for 30 seconds. And I don't know if it's faster or slower. We're gonna find out. All right, here we go. I'm gonna do my best. All right, so for some reason, lighter mass, you should have to put less force in it, right? Should be less force. So maybe I give it too much force, but I'm gonna give it a try. I find and you will find too, if you're a hooper at all, you'll find the more mass there is in the hoop, those thick, heavy hoops are so much easier than the light ones. The smaller they are, the harder they are. And if you're a smaller person, you can do them easier. All right, so here we go. 4, 5, shoot. Okay. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And we're gonna stop at 20 seconds. So we'll triple that. I know that's not gonna be very accurate. Maybe we should try it again. All right, I'm willing to try it again. All right. We don't have time. Okay. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, okay, I did 15 in 20 seconds. So let's see if we 15 and 20 seconds. If we take 20 seconds, let's see, we're not doubling it. You know what? That's what we're gonna do. Do one more 15 and 20 seconds. Okay. So let's take 20 divided by, or 30 divided by 20. It's 1.5. Okay, so if I did 15 in 20 seconds, if I take 15 times 1.5, that would be 30 seconds. So about 22.5 in 30 seconds. And then we could double that. I could have done this a different way. So 45. Okay, so 45 rotations per minute for the small hoop. All right, let's look at that data now and see. And I'm curious to see how you guys did at home, if anybody did this using hoops, or if you used to do it with a bucket. I'm wondering if it's any different with a bucket or a pencil. I've not done this before. This is new. Looking for alternative things that you guys could do, you know, if you didn't have hula hoops. So, oh, and you can see my sign now a little bit better. Newton's second law back there. Okay, so let's take a look at our data. Go sit down. Okay, on my yoga ball. All right, so let me look at our screen here. Okay, so maybe you guys can remind me. So Cody, can you tell me what was our data for the big hoop? How many rotations per minute did we say that was? Cody, I unmuted you. Cody K?
Wasn't that like 36?
I think it was. I think you're right. 36. Okay. And then we doubled it, so that was 72. Okay. So you guys can put in, if you were doing it at home, put in your own data. But if you were using my data, then the big hoop was 72. All right. And I'm giving Dojo for helping out, even if I call on you. It counts. All right, Cody. So anybody want to tell me what our data was for the medium-sized hoop? Oh, shoot.
40?
40. Yeah.
Wasn't that like 40?
I think it was. And then, yeah, that's right. It was. It was 40. Who was that? I'm not sure who shared that.
Me.
I see a chart or a chat here. Yeah, imagine saying 70 anyway. 70, or wasn't it 80? 40 times 2? Yeah, 80. 80 for the middle. Yeah, imagine saying 80 and PJ saying 80. Okay, I'll give you guys your points too. Let's put that in. Ah, excuse me, nose is itching. All right, 80. Okay, PJ and imagine. Can only imagine. I had that song stuck in my head. Yeah, okay. So, there you are. And then the smallest hoop, we just came up with, what do we say? We doubled it. It was 45, yeah. Okay, so, oh shoot, that's right. We've got to do this 3 times. Darn it, I forgot that part. Okay, so let's get some more data. All right, let's do this again. So, now big hoop again. I'll do this one a little quicker. You know what? Let's actually. Okay. I'm going to change it on you. All right, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Uh-oh. And 10 seconds to go. All right. So let's see, that was 20 seconds. So we did that again. Oops. What did I just count again? What did I just count? 45? No. 29? 29? I did. All right. So 29 times 1.5, because I only did it for 20 seconds and then it fell. So 29 times 1.5, 43.5. All right. So let's put that in, write that down on your data sheet, 43.5. And then don't forget, because I'm going to ask you for it again, because I'm going to go with my next hoop. All right, purple lightning, medium-sized hoop. All right, get your timers ready. Two hoops, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm having trouble here. 11, 12, 13, 14, 15, 16. All right, 16, 15 seconds, so I can just double that. 32. All right, so let's put in 32 for that. So 32, and then our last hoop. And 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we'll stop it at 12 for 20 seconds. That wasn't right. Sorry, I didn't do that right. All right, again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. All right, that was 15 seconds and 23. So if we took 23 and doubled it, that would be 30 seconds. So that would be 46. So then we would double that to make 1 minute, which would make 91. All right, let's go put our data in here. Okay, so you might need to help me. Okay, so we just said that this was 90. 92, and this one was 36, and we needed to double it. So 60, 72, and this one, what was this? Was this 45 plus 2? Who remembered that first one? Anyone? Yeah, somebody.
33.5.
33.5?
43.5.
43.5, and then we needed to double it, right? So 43 and 43 is 86, so 87. Okay, then one last time, darn it. Okay, 15, we're gonna do 15 seconds and we'll times it by 4. All right. Big hoop. All right. 15 seconds, and we'll multiply by 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I think when it came apart, it had some trouble. All right, 18 times 4. Somebody do that one for us. All right, do it. 18 times 4. Gotta do the next one. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There's probably 17. Dropped right before 2 seconds. So, all right, 17 times 4 would be that one. And last one. I had no trouble doing this before, but of course, in live, in front of people, different story. Okay. All right, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And there was 4 seconds left. So great science. We'll go with 18 probably if I had done 2 more rotations about that. So we'll do 18 times 4, which is the same as the first one. All right. So 18 times 4 is, what'd you guys get? Come on. Anyone? All right, we're low on time, so I better just get that in here. All right. So that was 72. This one was also 72. And this one was a little bit slower. That one was 17 times 4, which was 68. Okay, so what you guys got to do now, and you're going to have to do this kind of on your own, but with the remaining about 3-4 minutes, I'll just walk you through what you need to do, and then you can do it. And if you have any trouble, you can come see me during office hours. But what you'll want to do for the rest of the data table here, you're almost filled in, but you want to you want to add up the numbers, and it says so right here. So you're going to add up the numbers for the big hoop, 72 plus 87 plus 72, and then divide by 3, and you'll get your average number of rotations in a minute. You're going to do the same thing for hula hoop 2, the medium size, 80 plus 72 plus 68 divided by 3, because there's 3 numbers, and you will get your average for the medium size, and then do the same thing for the small. Okay, so now looking at a couple of these questions, who can tell me which hoop, or if, did anybody do, raise your hand if you did any of this on your own. Did anybody do any of these? No? Holy cow, I don't
The
even have,
bottom?
most of you, have you left me already? I don't see a lot of
Are you talking about the analyzed data?
I asked you if anybody did the lab along with us. Did anybody participate in actually doing the lab?
I don't have a hula hoop.
Trevor did?
No, I
Okay,
don't have a
so
hula
did
hoop.
you use your bucket, the bucket or the pencil, the other alternative things I asked or suggested, I mean?
Nope. Not
Okay, so then you didn't participate.
Yeah.
Okay, so nobody participated. All right. Okay, so I can tell you from my experience that the bigger hoop, my Batman, is usually a lot easier, and it has the most mass. When it broke right before I started, it actually, it messed it up. I think it's about done for now, unfortunately. But the larger massed hoops, or the larger massed buckets, or the larger massed rubber bands, they all should have been easier to spin. You would have had to apply more force, but once you got them going, they should have been easier. And at least that's what I have found. I'm not sure about the rubber bands or the bucket though, because I actually did not. Well, I have done the bucket, and you can fill the bucket with water and spin it around. The water won't even come out if you do it right. So Once you look at the data, you can analyze it and answer number 2. Can you see a clear difference in the number of turns recorded for the different hula hoops? Is one clearly faster or slower than the others? Like, more or less spins. So once we look at these 3 numbers, you're going to compare these 3 average turns and see which one was greater. Just kind of looking at this data without taking the average, it looks to me like the bigger hula hoop had the most rotations per minute, although I'm not quite sure until we get the average. And this is why we actually do more trials, because when you mess up on one, it's going to be hard to depend on one data, or on one trial. So we did it a few times and then we averaged them. Yes, Trevor?
Yeah, the bigger one had the most average.
Okay.
I did the math.
You did the math?
Yeah.
Okay, excellent. What was the smallest one's number?
The small one, Hulu 3.
Was how much?
It was 69.666, but I rounded up to 69.7. So.
Okay, so about 70, and the bigger one?
Yeah.
What was the biggest one?
77.
77. Okay. So pretty close, but yeah, the bigger one was faster. Okay.
And then Hulu number 2 had 74.
Had 74 also, right in the middle.
Mm-hmm.
Or I mean, as the same as the small. So the small and the medium were the same?
No. The small one was 69 point,
Oh yeah, that's right. And the middle one was 74 and the large one was 77?
Mm-hmm.
Oh, okay. Well, that worked out pretty well, actually.
Yeah.
So then depending on what you guys said for your hypothesis, does the data support the conclusion, why or why not? You're going to need to look at what you said. Did you say that the larger hoop was going to be faster, or did you say it was going to be slower? So you'll want to take a look at that to answer that one. And then number 4, think about the mass of the hoop. How does Newton's second law explain the acceleration of an object? How would mass of the hoop affect the force you must give it? So we've said this several times, that if you have more mass, you have to add more force to it to make it accelerate, according to Newton's second law, force equals mass times acceleration, right? Back there. Yeah, so then the question was, how would the mass of the hoop affect the force you must give it? You actually had that same question in Pennies from Heaven and Great Tankini. You have to apply, I'm not going to say it, but we've said it just a few seconds ago several times. All right, so make sure you're understanding the question. The question is about how would the mass affect the force you must give it? So would you have to give it more force or less force or the same amount of force? That's basically what I'm looking for here. And then question 5, what does Newton's law of inertia, the first law, say about an object in motion? Apply this to the hula hoop. Explain the motion of the hoop in terms of that. An object in motion stays in motion until an unbalanced force acts on it. So explain the hula hoop's motion with that. The hula hoop stays in motion. Keep staying in motion at what speed? At what, same speed, same direction, right? Unless, so you answer that. I basically just did for you. Okay, number 6. How are we doing on time? Oh boy, I gotta go. Okay, question 6, you are looking at Newton's third law. Every action has an equal and opposite reaction. I've given you a hint here. If the action is the force of the body on your hoop, you're pushing on the hoop, what is the equal and opposite reaction? Back it up. Force of body on hoop, back it up, hoop on body. So force of the hoop on your body, equal in magnitude or force, opposite direction. Centripetal force is asking about what direction is your force. Is it pushing out or in? And then a question to think about, some hula hoops have weights inside them, little lead weights. Sometimes they even put like water or something in them to give them, well, actually, I'm not going to answer that question. Why? Why do you think? All right, so I have to go, guys. Unfortunately, I was going to try to answer some questions with you, or let you answer some questions with us, but I've run out of time. So check this out on YouTube. If you need help, come see me in office hours. And this is due on Friday at 2 o'clock. Have a great day. Come see me later today if you don't understand, okay? I'll have no problem helping you. All right. Bye, guys. Bye.